Well, again, I appreciate everyone being here. Part of what we want to do is improve this multi-way communication between all interested parties. Often at CZO all-hands meetings, I show up and interact with some of the investigators and PIs, and then we have these IMC, we've had multiple meetings with the various data managers, and often it's just the data managers and some of our team without PIs present. And so it's often the case that not everyone gets to know all the people who are involved in both directions. So for example, it's easy, I think, for investigators to forget that there's a whole team of people doing most of the work behind the efforts of the National CZO Data Team. So why don't we start by just doing a really quick round of introductions and describe your role or interests in the management of Boulder Creek CZO data. We're going to go in the order that people are listed here on the notes file. So why don't we start with Eric?
Yeah, so I'm Eric Parrish. I do a lot of our web stuff and GIS and graphics.
Super. Joe?
So yeah, Joe Mills. I'm a grad student with Suzanne, and I'm a consumer of the data, and just generally interested in how the data system is going to be set up for more cross CZO.
Mm-hmm. All right, Jerry.
I'm Jerry Tebbets, actually now Jerry Fate, and I am the data manager for Boulder Creek CZO and handle most of the back-end support for data.
Great. Nate.
Hi, my name is Nate Rock. I'm the field manager for Boulder Creek CZO, and I produce a fair amount of data.
All right. Clayton.
My name is Clayton Jensen. I'm the lab manager for the Boulder Creek CZO, and I perform our water chemistry analyses.
All right. Suzanne.
I'm the PI Boulder Creek CZO.
All right. Super. Now we're moving on to our team. You can see in the notes file there's a link of people here on the criticalzone.org website that from Boulder Creek who have a tag of data management and server infrastructure. Well, there are 2 of you listed. It'd be great if more of you are listed, even if you just have an interest. Jeff.
Hi, this is Jeff Horsborough from Utah State University. Hopefully you guys can hear me. I have a bad connection, but civil and environmental engineering. I'm working on the CZO data team. I've led the ODM2 effort and have a background with the quasi-hydrologic information system. That's kind of how I got involved with this group.
All right. I'm Anthony Oftenkamp. I'm a geochemist who got involved because of interest in integrating data. My primary role is actually the kind of the coordinator of all the CZO data efforts, but I've been quite heavily involved with the conceptual design of the ODM2 information model, the resulting YODA file format, and the related ODM2 vocabularies.
Ilya Zaslavsky from San Diego Supercomputer Center. I'm a geographer by training, but have been involved in various computer science pursuits in the last many years. Our group includes Dave Valentine and Tom Whiteneck, also working on this project. We've been on the regional team that developed the first architecture for ingesting display files and serving them as services, so we're responsible for the search interface, web services, things like that.
Tom.
Hi, Tom Whiteneck, and I work with Ilya, as you just mentioned. Primarily working on the back end with the metadata and the search interfaces.
Sarah.
Hi, I'm Sarah Damiano. I work under Anthony at the Stroud Water Research Center. Doing pretty much the same things Anthony does, but to a lesser degree.
I would argue with that, I think, to a greater degree, but we all have our specialties. Sarah really dives into the details. She's the architect of the ODM2 units vocabularies, which I think are an amazing contribution. David.
myself, I'm David Valentine. I work with Ilya Zaslavsky, responsible for some middleware for Water One Flow Web Services, information catalogs, and a variety of other information models.
Kirsten.
Yeah, I'm Kirsten Nehnert. I'm the director of the Interdisciplinary Earth Data Alliance, or AIDA Data Facility, and am involved with the Critical Zone Observatory data through our geochemical data systems. I've been working with Sue Brantley on ZZChemDB and efforts in integrating that with EarthChem and making it web accessible. The AIDA Data Facility also operates the system for Earth sample registration that provides persistent unique identifiers for samples, the International Geosample Number, and that's another service we're bringing into the CZO data project in being a registration agent for CZO samples here. Yeah, I think that was it.
Great. Megan.
Hi, everyone. My name is Megan Carter. I am a data manager at the AIDA Data Facility that Kirsten just mentioned. I am your point of contact for helping obtain IGSMs for your physical samples and sites, and I can also help you with registering or publishing your geochemical data sets in the EarthChem library and obtaining DOIs. I am trained as a geochemist. I'm actually a former member of Sue Brantley's lab, so I've spent a lot of time in Shale Hills, and I'm looking forward to talking with you all.
Super. If you follow that link that's in our notes file, you can see our listing and our contact information, get some pictures of us. Two members of our team that aren't here, actually there are three of them. David Lubinsky, who you know, does our website and actually has helped quite a bit with the data set listings. We'll talk about that in a bit. Emilio Mayorga is in charge of the visualization system. David is not actually explicitly a member of our team, although he was an early architect, but he's also overseeing HydroShare, which we'll talk about a little bit. And Chun Han is doing web services at San Diego Supercomputing Center. So we've got a pretty big team. We described quite a bit of our various areas of responsibilities for our team, and I'll point out that, as we're going to discuss in a little bit, 3 weeks ago, we massively expanded our guidelines underneath the Submit CZO Data web page from one web page to actually 10. And underneath each of these major topics, we have contact names so that you can kind of have a better feel for who's in charge of what, because we realize that that has been often quite unclear to CZO investigators and data managers and data users. So we're trying to improve that level of visibility here with these various guideline documents. So with that, I want to move on to maybe doing a brief overview of the rest of the agenda and then getting right into things. What we'd like to do is spend the next 40 minutes or so getting to learn about your local data management approach. All the CZOs manage data locally as they choose, and we'd like to hear about the details of how you all do it and your approaches. We'll watch a presentation for maybe 20 minutes or so and then have some Q&A as we ask clarifying questions. These notes have been filled out in advance, so we'll try to answer the rest of those. We then want to open up the floor to any questions you all have about our recommendations that I just pointed out. We realized that that website was massively expanded less than a month ago, about 3 weeks ago. So we want to give you the opportunity to go to ask about it, and we found in previous experience that especially the investigators benefit from a brief tour of the content that's there. And as we describe that content, after hearing about how you do things, we'll then kind of open it up into a discussion about how we might better help you meet some of the expectations and also optional approaches that we are recommending for sharing data within the CZO network. And then at the very end, we'd like to talk about future needs for the CZO project. Most of this discussion that we'll have today will be about the funded scope. As you all know, we when our team finally received funding in March of 2013, the landscape of the world of cyber infrastructure and data sharing had changed quite a bit. So we took some opportunities and really benefited from some major advances via EarthCube and with the Observation Data Model 2, which was funded separately. So we've been working quite hard in the last 2 years or so to develop products. Most of that work was completed in the winter and spring of this year, and we're entering a phase in the last 6 months of our project to basically be an outreach and train people. But also in these last few months, we will be starting a conversation with NSF and with CZO PIs about where to take this project in the future. So we want to hear a little bit about that. So any questions about the agenda? I'm going to be passing the presenter ball to Jerry. Is that right, Jerry?
Yeah, actually, if you, I guess I'll just run that that same slideshow that we sent you or posted.
You know, if you like, I can run the slideshow and just present from my laptop, and you just tell me when to advance. You want to do that?
Great. Yeah.
Okay. This will take me a second. So while I'm firing that up, any questions from anybody about the agenda or anything? Oh, I don't have access to get to that file.
Darn it.
If you could put that file in this directory that I have linked to right here, then not only would I have access to it, but so would everybody. Just drag it and drop it into that place.
Darn, I thought I did that. All right.
It's not there. Well, tell me once you get it there, Jerry, and I will refresh that directory and.
All right.
Not there.
Oh, it's so crazy, frustrating.
Yep. No worries. You want to present from your laptop?
It's not allowing me to just copy and paste, so I've got to download it to my hard drive and then upload it to your directory.
Yeah, Google Drive doesn't do copy and paste. You have to do this thing called move to or add to.
Yeah, and it only gives me my folder options. It doesn't give me your folder options.
That's right. So what you'd have to do to actually add to or move to is that you'd want to move that entire higher level IMC directory. I'll put that link there into your My Drive, and then that should work. So this directory right here.
This one, the one-on-one consult?
Well, you could do that one, but here, that CZOData IMC, I just created a hot link. That's an umbrella that has more stuff that would be of interest to you.
Like going between 5 different pages. Okay.
So in the while Jerry's doing that, maybe might be useful to hear from Suzanne and some of the other investigators and folks at Boulder Creek, whether or not you've had a chance to look at any of our new online guidance on how to share data. Not really how to, but it's a combination of how to and what's expected and with instructions.
Well, here's Suzanne, and I can tell you, I'm sorry, I haven't had a chance to go look at things.
No worries.
No, I was in China last week.
That's right. I was talking to, just had lunch with Diana Carwin, who was with you on that trip.
Oh, yeah. Okay.
So then we're going to do we'll do a quick high-level overview, hopefully relatively quick, of the essentially 7 expectations for CZOs for sharing data, and then the 2 optional approaches for sharing data that the CZO data team will help support if a CZO chooses.
Well, while Jerry is uploading her file, I don't know if this is in her, I can't remember if this is in her presentation or not, but our data management plan
oh, yeah.
awarded a prize on the CU campus as the best data management plan in physical sciences, and is being used as an example for others to emulate. And that was basically, Jerry kind of slightly modified what we had in our proposal to reflect what we actually do. And I just thought that was kind of a very nice thing to be noted for our data management plan. That's a little different than, the data infrastructure that you're building, but.
Yeah, that's actually, but it's very related. What we're trying to do is facilitate data sharing. Unfortunately, that document is also locked down to people that I don't have permission to open it, so.
I'm so sorry. I should just add you to that directory in my Google Drive, because I share it with all the guys here.
If you add me to the directory, I can do pretty slick stuff like kind of cross, because, Google Drive, it's all virtual directories, right? So I can put it in multiple directories at the same time where it doesn't move anything that you've done, but it also makes it available to other people.
Okay, that's what I'll do.
But for that, I need access not just to the file, but to the whole directory to pick in. Well, maybe not. Maybe I could do it at the file level. Okay, you tell me, Jerry, when I have access.
I just sent you an invitation to our shared Google Drive directory.
Okay.
I know what it did. The link that you sent me to open, I opened in a different Gmail account that I have instead of my school account, and so it wasn't uploading.
Then you're forevermore not in the right place.
Nope. It's too smart, and I don't feel like fighting that right now.
All right. I'll figure this out. I think this will do it. Perfect.
Oh boy, that was so worth it.
Okay.
Just that slide.
Yeah.
All right. Go ahead, Jerry. And I will figure out how to, present this.
Okay. So actually, the first part of this we kind of used at our Boulder Creek annual CZO meeting over the summer. And so some of this you guys already know is how to get to our site and our data. And that's just what the first couple of slides are, is how we are using typically the main critical zone website to give to people and have them work their way down through to get to the data. We don't just send them directly to the data link. That way they have options and they can see your search capabilities and stuff like that.
Mm-hmm. So you tell me when to advance. Whoops.
Yep. You can go ahead. This is just, going to our data. And these are all of our data sets right now. We do have one live metadata feed, and the rest are historical data that we input into the database. And we have chemistry data and discharge and a whole bunch of, but we can go back into that later on. Go ahead and click the next slide. So this is also the information that we give to all of the folks that are submitting data to us and people that are requesting data from us. We point them to the website where we have, you know, the data sharing and use policy on every single web page.
Super.
Okay, click next. And then this is where, this is really the meat and potatoes of what Eric and I really work on, and that is when people want to submit data to us, we have in the past requested that they send it in CSV format and then their metadata in text format, and that allowed us to put it in whatever format we wanted to. And we've been following the ISO 19115, and that's what got us on the path to converting our metadata to XML files. And we're still in the process of doing that. Right now, they're CSV files for the majority of them, I think. Yeah, so all of them are CSV files right now, but we're going to convert all metadata to XML. And our data itself is still going to be downloadable via CSV files. And that way people can put them into whatever kind of programs they want. And Eric created this link on the site there that that you can click on, and it just downloads a CSV file, and they can email it to this BC CZO data web or email address. And typically, what I do is this is how I start communication with whoever's submitting data, and I open up a Dropbox directory for them so they can drop all their data in there, and then we can ask questions if I need more metadata or more explanation as to what their data is or how it's used. You can go ahead and click on the next slide.
All right.
And this is an image of our metadata form that we ask people to fill out. And I think Eric based this on the LTER.
Yeah, the LTER NIWAT here has
NIWAT, yeah. So
things off of that and then modify it to our tailored to our needs.
Yeah, and you can go ahead and click on the next. I think this, this is just the second page of that spreadsheet, so you can see the options that they have there to select from. And you can click next. There you go. So yeah, right now we are collecting all the data in CSV format. I take that data and I make it so that I can import it into an Oracle database. I use Excel macros to kind of make sure there's no wrong characters in the Excel file that'll blow up the upload. And I use JavaScript to upload that data into, it's kind of a servlet that I use to upload that data into the database. Okay, so all of the majority of what we kind of focus on is we make sure that each data set has its unique location ID, and a date timestamp is how I create unique lines within a table on a database, and each data set has its own table. And let's see. Once I update the database and I update the web page to reflect new data dates or date ranges, I update that to CMS. And if there's a new data set that comes in, I create that in CMS as well. And yeah, like I said, I use JavaScript. It's the back end of our web pages, essentially. And that allows people to select date ranges and other information depending. So like our metadata, there are a lot of different options you can choose to select. So you don't have to pull down the entire contents of that database or that table. And what we're working on right now, actually, Nate, our field manager, is working with me on getting IGSNs for their field samples. And you kind of already answered one of our questions, so I think he's going to be talking with Megan because he's got a couple questions about IGSNs. And also, I'm working on getting our WaterChem data configured to go into EarthChem and DOIs for that. And yeah, the system we're working on right now is a legacy system from the old data manager, and our backend and our location IDs don't match up at all. So it makes a lot of work for Eric and I right now. And we have a lot of documentation telling us where things are because it just doesn't, it's not intuitive. So what we're going to work on this winter is rebuilding the back end. So I mean database tables and web pages to match our location IDs so everything is linked and it's really easy for somebody to come in and tie it all together. And yeah, and then the last thing is I'm working on for the non-chem data, getting some DOIs associated for those. And you can click the next screen. And I think that's where you were.
More slides, but
do you want to turn your?
Yeah, why don't you mute yours, I guess.
You still there?
Can you hear Eric?
Nope.
Here, you can use my computer if you want.
Okay.
Here.
Okay. So what you see in this slide is an example of those unique IDs, and we put them in the name. For those of us who use those unique IDs, it makes it easy to scan through and find your data set. Go ahead and advance slides. Currently, I'm actually this is already done, but I'm putting a lot of our metadata actually on that first CMS slide, including downloads.
Sorry about that. Yeah.
And of course, I put dynamic maps in all of ours, as well as better tied in the related data sets. Okay, advance slide. And then we have our query pages, which Jerry was talking some about, and I've actually put all those things in there as well, including all the metadata is really kind of there, so you are able to see it at every level as you drill down. Of course, we have another dynamic map, metadata downloads. We also have these log files that make them accessible, as well as any other information that may be germane for the metadata. Advanced slides. This is an example of the metadata, and we've got the location descriptions. We've got the lat-long coordinates for them. Let's see, sorry, the screen's a little small.
Sorry, I have
and again,
a small screen.
Yeah, and again, I follow kind of the LTR model for their metadata, and so it kind of matches that type of formatting. And there's a reference for it right there. It's actually written by Seastead et al. Advanced slides, please. Oh, that's it.
Oh, that was it. So that's just a quick run through of what we're working on and how we use our system. Nate, did you want to talk anything about your field data collection?
Do we need clarification on this part?
I can just a little bit.
Okay, I guess I can just speak briefly to our, data collection and initial QA/QC efforts. So obviously we have a fair amount of data loggers out there in the field. We try and get out there and download everything monthly with a manual download. Currently, go out in the field with a laptop and plug in directly to your data logger to download the data. We are about to put the order in to make our main study area an RF network, and then we will have lots more live data to put up on your on the new live page. So looking forward to getting that up and going, which will sure involve a whole new set of troubleshooting.
Yeah.
once that's brought back down to the office, I upload them to a master Excel sheet, and I do basic statistical analysis to it, plot them up in Kaleidograph to get a secondary visual on the data itself, and then I update to a distribute tab, and then monthly Jerry will go in and pull out of my master Excel files and pull those up to the website.
Perfect. All right. Does anyone have any questions from our team or any team?
The time to ask this, but I'll start out there. So, Jerry, do you know if there's any plan to be able to kind of query the database directly without, so I use R pretty heavily for all of my work, and being able to, right now I just use kind of pasted HTML strings to be able to query it, and if I could do that using SQL or something, that would be really nice.
Are you on the Colorado EDU network?
I can VPN into it, yeah.
So what I'm thinking is we could maybe work it out so that you could create an ODBC connection to our Oracle database.
Okay, yeah, I've worked with that at the survey.
I think that you just read-only access.
Yeah, that'd be perfect.
Okay, I can talk to OIT and see if they could do that. Otherwise, that pretty much. Oh, sorry. Go ahead.
I was just trying to think of ways, to do that without having to do. Now that's great for me, and that'll work just fine. But moving forward, if there's a way to have it easier to link different R models or Python or whatever to our database and not have to do the secondary data import step.
As far as I know right now, our web infrastructure doesn't allow that. We don't have any options to do direct data connections through the web page. If you had some suggestions or ideas where other sites have implemented that, I could take a look at it.
Okay. Yeah, I mean, I don't right off the top of my head, but.
Okay.
Because I use, like I said, I use ODBC here, but it's a really old system at the survey. But. Yeah.
Yeah, otherwise it's just a matter of downloading the entire content of the database via CSV file, which actually it's not that huge because, it's not like we've got images in the database or anything like that. It's fairly small.
Yeah, so is there a way through the web to download the entire database like that?
Not right now.
Okay, that seems like a pretty...
Well, something we had considered doing, and I think we do it for one data set, I can't remember which, but we take the entire table and put it into a CSV file, and you can download that. And I mean, that's certainly an option we could do. Is every month when I update these regular data loggers, I could just make an export of that data into CSV file and make it a button to download on that web page. That's totally doable.
Okay, yeah, because it's generally a lot easier to do any subsetting and stuff within, R or Python than it is to try to pull individual files and then merge them.
Sure.
Cool, great. Well, I'll send you an email about the ODBC thing too. But.
Okay, that'd be great.
Awesome, thanks.
So I have a bunch of questions. It seemed like, well, first of all, I just mentioned that I was able to to basically cross-share these the slides that you just showed and the data management plan so that they are viewable by anybody on this phone call, if I'm not mistaken.
Thank you.
So these new links should work. As you were describing in one of your early slides, you were kind of talking about how you were importing these metadata profiles. Let's see here. I'm going to move. into an Oracle relational database using JavaScript. And then you talked about the CMS being updated, and then you showed some images near the end. Maybe I should just actually show you exactly what I'm talking about. So you're talking about the CMS being updated, but then you showed some images of what some of that looked like, and this basically looks like our website. So I have a question. Is your system linked to the main criticalzone.org website, or are you did you work with David Lubinsky to basically pirate the kind of the front end user interface, or pirate isn't the right word because we're very happy for you to share. But
those are independently run by us at that level, so they're on our server. So if you look at the URL when you get in that feed. So
I can't. It's not shown here, I don't think. This screenshot doesn't show the URL.
It shows the page. But yeah, so they run from CZO.colorado.edu. And then there's just links in between the national and the little site we have here. And I did just kind of, of course, as you know, I helped Dave Valinsky develop all that. So I just used that.
Yeah. So, so is it the exact same website, or so what's the process of moving from one to the other?
Actually, if you pull up the national web page, I can show you.
All right, I've got the exact data set open right here.
Okay, so if you look at the address there,
it's criticalzone.org.
Criticalzone.org, Boulder, and scroll down. And click on the Patasso, link.
All right, that's an HTML link,
Yep. And now that address is hosted here on our site. So this page is hosted by us.
Got it.
Yeah. I wanted to create a good user experience so that it wasn't jarring as you went from site to site.
Yeah. So then there's one extra level of being able to fetch the data in the logs, right? But there's extra stuff here. Got it.
Yeah.
That's really useful to know. So it sends the user to a customized system with extra capabilities.
That's right.
We didn't have that kind of capability on the CMS.
Yeah, because I guess CMS doesn't have that capability to dive down into our database.
Right. That was never the intent of what we developed at criticalzone.org. Okay.
Right.
Any other questions from our team to try and understand things? Let's see here.
You mentioned that you're using the ISO 19115 metadata. I'm just kind of curious where that fits into the picture, because I know a lot of the data management stuff, we're also creating the ISO 11, the file. So I'm curious where that comes in.
Well, my understanding is it's just a standard that the NSF requests that we use. So that's why we're going to convert everything to XML.
Yes and no. So ISO 19115 is is an international standards organization. ISO metadata format for geographic data for multiple files that are stored that can be kind of grouped together as geographic data. NOAA has adopted it as its recommended format for sharing data. NSF themselves hasn't made any recommendation at all for CZOs.
Eric, but I think we just did a search for that ISO data management.
We discussed that. We Googled ISO.
Yeah, we Googled it, and that's what led us down that.
Yeah. So that said, I wasn't trying to sound negative about it. So it's a great format, but the reason Tom was asking about it is because it's exactly the format that we use here. So every single one of the metadata profiles at criticalzone.org is converted into an ISO 19115 metadata profile that's then fed to search.criticalzone.org. So
you're saying the data that's in CMS is converted to...
Yeah.
Okay.
So what David Lubinsky worked with Tom to do is to basically take that, and I'm just going to go to search.criticalzone.org. This is a geoportal, because once it's in ISO 19115 format, there's lots of interesting things you can do with it. So we kind of go straight to that. Let's see here, Batasso, right? How do you spell Batasso? I guess I got to spell the whole thing, right? And I can click on meteorology, and what I'm doing is demonstrating the faceted search capabilities of search.criticalzone.org. So right here is the profile that is created automatically, the metadata profile from this data set listing at search.criticalzone.org, and the XML of that in ISO 19115 format is right here, and it's all compressed because of the way my viewer is set up. So sorry, it's like a lot of the actual content is hidden here. This is very hierarchical.
I think we were trying to look for that, what, a couple months ago?
Yeah,
and we couldn't find it. So this is awesome.
You should have given us a call.
Yeah. So one of the things CMS doesn't allow us to put, or we just don't put as much data as that we have for each data set into CMS, because we have log files for each data logger.
Which we do have links for.
Which we have links for, but they're not searchable right now on this site.
That's right. So I mean, it seems like there's kind of like two layers of almost identical system, right? I mean, what you have here does have some extra advantages, and you are adding additional information over what is listed at here.
Yeah.
And it seems like you have an automated way to transfer it, but you know, the point of what we developed here was to actually then automatically harvest that into ISO 19115 so that it could be federated, that information could be federated using a geoportal server, which is designed to basically be a catalog of ISO 19115 metadata documents.
So should we be taking our logs and stuff and putting them in CMS, or?
Yeah, that'd be my question. Do you want us to put links in the CMS to the logs, et cetera? Would you want us to put links to our logs, et cetera, into the CMS so that that would get picked up as well?
So
we certainly build links in there.
So the truth is that one can get to them. I mean, you've got enough information here that one can get to them through this kind of two-hop system where you, and this is designed to be very flexible to allow for things just like this, right? So that we can, for example, link to USGS data that we don't actually manage, but they're raw data. You know, one can pool together in a way that allows it to be discoverable, so you know what USGS data is available, even though we don't have access inside their system. So what you're doing is works, and I don't know if there's any pros and cons for doing it, for having your data logs directly accessible via here, but let me click on that, right? That file could be, that link, since it's a nice URL, could be listed here too, you know. I mean, it's really up to you, and I don't know if there's anyone else in the team who thinks there could be a benefit.
I think there is. I think more information is always better.
Yeah.
So it's hard to implement. It is just a URL.
Uh-huh.
I just got to find a good place to mix and make the link within the CMS.
So the kind of the next question I have is that when I look at this form, it looks really very similar to the back end of a data set listing. this form is actually potentially super useful for other people. And at first I thought that this is what this was, is that it was actually an entry form so that you could take this information and type it into the the criticalzone.org content management system. But this is very specifically tuned for your system.
Yeah, it's for our metadata system.
Yeah. Well, it might be something for us to look at and play with.
Okay. Also right there, so.
Yeah. Yeah, and I downloaded it so we can play around with it too. Does anyone else on our team have other questions about how things are happening at Boulder Creek?
You know, actually, this is Jerry again. I'm wondering if, since now I can see where the XML files are being auto-generated from CMS, would we be just be doing double the work by converting our metadata files to XML?
Want them to match.
You want them to match.
Yeah. You know, you don't want to have their system have a different file than us.
Yeah. Okay. Yeah, that's true.
I mean, we can work with you perhaps on finding a way to convert your spreadsheets into XML. I mean, and maybe this is a nice, you know, people see that as a form, right? It comes as a form, so. That's one way to look at it.
There may be one additional benefit of trying to do this together, because when we convert these to XML and then pass that through Synergy pipeline, we add some additional information to these ISO documents. For example, we browse the abstract and see if there are some keywords that would make sense to add that would describe instruments, variables measured, mediums, platforms, and a bunch of other things that happen to be defined in ODM vocabularies and in other ontologies. And then this information gets referenced to ontology IDs, so that when somebody would come to that central search interface and will look for, you know, for instruments or whatever, for some documents, they will be able to use semantic information embedded in these documents to do kind of more advanced search, even if the specific terms are not used in your abstract. These documents would still be found if they are related in an ontology. So you may have heard of these new buzzwords such as linked open data, that's what many repositories are trying to be represented through, and that's the first step towards that. Linked open data is essentially metadata descriptions that include semantic references and thus and therefore allow to cross-link different descriptions via such references. In canonical linked open data, you present this as RDF. In our case, conversion to RDF would be an additional step, but basically all information is there. So that is an additional benefit of kind of doing this the ISO way and getting this through the pipeline.
Yeah, you know, one of the things that our team had to do was, so ISO 19115 is super flexible, which has its pros and cons, and a lot of these international standards, because they're built by international committees, are so flexible that sometimes it's not as useful as you want it to be. So NOAA, even though they've adopted it, has been kind of asking for certain profiles to be developed so that the machines can actually talk to each other and know what they're talking about, because sometimes these fields are so open. So we had to map specific information into the fields of ISO 19115, and you've had to do that too. What's kind of on our long-term plan, although we haven't gotten to it yet, was to essentially submit this to NOAA and some other governing authorities so that other people start using the same mapping, and then it increases the power of being able to exchange information using geoservals and geoportals. So you've already, and plus you've got a very nice form that we don't have. You know, this is all kind of all code stuff. So there may be some really nice synergies, especially if you have a JavaScript that reads this and spits out an XML thing. There may be some pathways for future collaboration here. But it'd be worth doing that rather than going at it alone.
Sure, yeah, that sounds good to me.
Okay, I'm gonna, I pasted in, by the way, this form so that people can explore it. People on our team, I found it on the website. There's a big button on kind of their main data website. Maybe I'll just paste it by clicking button here. All right. So I'm thinking, looking at the time and everything else, that we might want to do just a bit of an overview of what our expectations are from the CZO data project for how to share data, and then I think we can from that see where there might be some things that you're all doing really well and other things where we might need to assist you a little bit in kind of expanding. But it seems like you're aware of a lot of what we've been talking about for a couple of years now, and seem like you're interested in doing a lot of these things. And so we now that we've got some clearer guidelines, hopefully it'll be easier for you and all of us. So I'm going to, if we're good, I'm going to just do a very quick high-level overview of what the expectations are for sharing CZO data and what the options are that we would support. Okay. So the Submit CZO data page, as I mentioned, just got expanded from 1 page to 10 with much more detail. Each page has a set of benefits and outcomes, like why it's worth doing, and then a list of instructions. So kind of at the highest level, you know, we want CZOs to share data, and there are 7 expected ways in which we want CZOs to share data. The first one is to list data sets at criticalzone.org. The benefits are that we create these metadata profiles that can be shared using GeoPortal. We've just been talking about that. I think you guys have that figured out, but there's a little bit more information about that at this web page now, at these links, that might give you a bit of a background. The next thing, which is relatively new, although maybe not very new, is that the criticalzone.org can receive any kind of file or URL, for that matter, as you know. CSV files, XML files, whatever, can be linked to. And one thing that was worth clarifying, CZO Data Central does not store any data. We're just about linking data and providing services for finding data and things like that. We'll talk more about where the data should be stored later, and I think you've already mentioned DOIs and EarthChem library, so I think you're thinking in the right direction there. So these files, though, to actually look inside the file, your web server, one of the things about what you've done is that you have the ability to query that data. You have it in a database. It's really useful. But it's useful only within your own data holdings in terms of that ability to integrate specific data values from different time periods or whatever it might be, to subset a very large time series, or to look for all calcium data in soil pits, in water, and in rock outcrops for a given area, right? So that kind of thing you might be able to do with your own internal database, but to kind of create that ability for integrating data across the CZO network requires that the data be shared in a uniform way. And back in 2010, people like Ilya and David Tarbotin developed the CZO display file along with Mark Williams, and essentially we are updating that with kind of version 2 of that, which we've renamed the YAML Observations Data Archive and Exchange format, or the YODA file format. So that specification is not fully complete yet, but we're close, and it's based on the observations data model 2, and we'll really have a lot of additional capabilities built around it. So if you share your files in that format, it basically is a self-describing archival format that it's the kind of format that data repositories and data centers really like because it's self-explaining. Ilya mentioned that a little bit earlier about those benefits. Plus, because it's wrapped around the observations data model 2, ODM2 conceptual model, it can be readily ingested into that and allows integration of data. I will mention here that this one of the things that you showed, this right here, you mentioned that it was from this LTR approach, which Mark Williams used as the basis for the display file version 1. Yeah. So this looks very, very similar to a display file version 1. And we took a lot of the ideas of display file version 1 and expanded them and made them much smarter in the YODA files. So what we're talking about with YODA files is just kind of an iterative step from what you're already doing. You can read about the YODA files online. So where was I? So that's something to maybe start thinking about. The next one is to use controlled vocabularies. You all haven't mentioned that very much, but I presume that you are using controlled vocabularies. But one of the things that that we've done is we put quite a bit of effort on developing recommendations about which controlled vocabulary system to use, and then how to use those controlled vocabularies in things like YODA files or CSV files. And one of the big things that we've done, a huge effort, was to develop control vocabularies for the observations data model 2. These ODM2 control vocabularies were kind of built about out of the best vocabularies we could find. We merged vocabularies from Quasi and AIDA and other sources as much as possible to create this ODM2 control vocabulary system. The benefit of the ODM2 control vocabulary system is not only that the terms are good terms, but for example, if we click on one of these, you can see that each of these terms has a definition. That's kind of an important part of a term, so people know if they're using the right term for the right thing. A lot of the vocabulary, it's a recommendation for control vocabularies. Neither Quasi's or AIDA's vocabularies always had good definitions. But then also, the vocabularies can be used are built in a system that exposes them as linked data via RDF or SCOS systems, which allows machines to basically read these vocabularies, and from a single term, such as core, it can find rock powder, it can basically pull out the definition and all the information about rock powder in one fell swoop. So that's one huge benefit of our system. But the other one is that it also combines with that the ability to have users request new terms to be in the list, or if there's a term that that is there but you want to add some information to it, maybe expand on the definition or whatever, the community also has the ability to request edits to the term. And that combination of a control vocabulary system being maintained within a SCOS data system, so for machine-to-machine interactions, and for it to be enable user input is kind of unique. So we're quite excited about that. We also realize that there are some reasons why it's still useful to use other vocabularies, and so now we have clear guidelines on when it's appropriate to use the Quasi vocabularies instead of the ODM2 vocabularies, and when it's appropriate to use the AIDA EarthChem vocabularies when those are the best choices. Any questions about that?
No, actually, this is kind of a good time for us to get all the information since we're going to be rebuilding the system on our side. We can do some consistency and some standardization on the back end.
I was always trying to point what I was doing towards this type of thing exactly.
Yeah.
That is super. If you're really building the system from scratch in the back end, we should also talk to you about the benefits of using an ODM2 database. So the next thing is IGSNs. IGSNs stand for International Geosample Number. They're globally unique numbers that have a humongous amount of benefits. They're internationally governed. And Kirsten Lennertz and her team is really one of the leaders, the global leaders, if not the leader in the use of these. One of the things that the International IGSN governing body has really decided is that the system is expanding beyond specimens to include all related sampling features, which are things like sites, wells, boreholes, etc. And we are really encouraging moving forward that CZOs register sampling sites, weather stations, stream gauges, soil pits, wells, etc., with IGSNs. There are an enormous number of benefits to that. One of them is that the IGSN system is hierarchical, which means that it can it maintains the relationships between sampling features. So you can, for example, if you collect some specimens from a soil pit, and you can relate to those two identifiers, those two IGSNs, and always find them. So if you include the sampling site IGSN in the workflow when you start managing sensors or collecting specimens, then it really will ease your data management. And I'm going to show you an example here from Lukio because they've done a nice job of doing this. Just a couple of CZOs have done this. But here's all the metadata associated with this rock core. From Lukio, notice that the system generates a barcode. There's a bunch of metadata. But the really cool thing here is that it tells you the parent, what specimen or site did that rock core come from, and what are all the siblings? What are the other cores that came from that same borehole? And maintaining that information is really an exceptional benefit. There are more benefits related to publications, and I'm going to let Kirsten, if she's still on, talk about that. But what we really would like to see happen is this workflow where sampling sites get registered, IGSNs, then that sampling site IGSN gets used in the workflow for all the work related to managing information from that site, and then that specimens that come from that site, you get IGSNs, maybe even before the samples get analyzed, maybe when they're being prepared before the sample is even collected, that they can use these barcodes. And the benefits are actually come straight to the scientist with respect to publishing data. Do you want to say anything about that, Kirsten?
Yeah, can you hear me? I needed to unmute, sorry.
Yeah.
Yeah, I mean, the use of these persistent unique identifiers, be it DOIs or IGSNs or increasingly ORCIDs, you probably, all of you who have authored papers recently noticed that publishers are now requesting ORCIDs as person or author identifiers to be entered. All of these identifiers come with machine-readable metadata profiles usually, and there's increasing collaboration between these various entities that issue the identifiers and register the metadata to link them all up. And what that does is a much better discovery of related resources from publications, including also software, actually, which is not quite my field that much, but that is clearly coming in as another aspect there. The other benefit is that by being able to sort of machine read and discover these persistent identifiers and really reference them unambiguously back to people, to samples, and so on, it allows to build bibliometrics, citation bibliometrics that, currently they, as you all know, they basically relate to publications. There has been for years now a push to also generate citation bibliometrics for data sets, but the use of data set DOIs in publications that people really reference those DOIs hasn't advanced as much as we have hoped. But we are also now pushing basically for the citation of samples that can ultimately also allow the tracking of samples and linking them up to the person or the program that collected samples, funded sample collection, preparation, and analysis. So it's a very interesting development. I'm just wanted to make you aware that actually the publishers are all working very intensely on these issues, and I'm going to a conference next week, which is a joint initiative of publishers and data facilities called the Coalition for Publishing Data in the Earth and Space Sciences. The meeting will be in Oxford at the Wiley offices, and all the major publishers from Nature and Science to AGU, EGU, and so on are present, trying to basically align their data policies, the procedures of submitting data that belong to publications, and one of the recommendations there is also to use IGSNs for the samples, for the samples referenced in a publication. So if there is interest, we can clearly set up in the near future sort of a webinar that very specifically focuses on this topic. There is also, I should mention that, an effort that related to EarthCube. It's a funded exercise within EarthCube that Yolanda Gill from the University of Southern California is leading, called the Geoscience Paper of the Future, where she teaches specifically early career scientists how to properly include software, samples, data in publications, how to reference them by DOIs and so on. We just had that course here at Lamont last week. Was very informative for students. They were very excited. So also at the upcoming GSA and at AGU. Okay.
Thank you, Kirsten. So
I actually do have a quick question about the IGSN. So we have these data loggers. Would we get one IGSN, say, per GPS coordinate, or would there be multiple IGSNs per sensor, or that's where I'm kind of confused on
No,
it.
the IGSN does not apply to sensor measurements. The IGSN is specifically intended for a physical object that you're generating, be it or that is there, like a soil pit, a core taken, a water bottle that you take back into the lab. It is a physical object that you're identifying with an IGSN. The identification of individual measuring points within a time series and so on, there are currently different approaches to that. In some cases, people use DOIs, but DOIs at some point, if it's thousands and thousands of measurements, is not really practical. There are other ways to generate unique identifiers for those. But if I understood this right, if these are measurements.
Yeah, I was just confused because it had weather stations, which has lots of different sensors and.
So here's the thinking. It's not for devices, but it is for what's called a a sampling feature, and a sampling feature is defined by the Open Geospatial Consortium's observations and measurements metadata standard as basically a place on Earth or a portion of the Earth that one collects data from in order to understand a feature on the Earth.
Got it.
So,
okay.
So a weather station isn't actually anything about the equipment, but it'd be kind of like that location of the lower atmosphere that one is making measurements from.
Okay.
Or the stream gauge would be like that cross-section of the stream from which data is being collected.
That makes sense. Great.
Yeah, so maybe we should remove somehow do a better job at defining what we mean there. Right, so it doesn't have to be an ex situ specimen that you bring into the laboratory, but it's definitely a physical part of the Earth. That's what a sampling feature is.
Okay. Yeah, that makes.
Did I do a good job with that, Kirsten?
Yeah, but I agree with you that we need to do a better job to define this. And I mean, we clearly have only fairly recently decided to include the sampling features to allow that being given IGSNs. There will be, I'm sure, there will be a fuzzy zone somewhere between IGSNs and DOIs, and we've had a number of discussions about that already.
Mm-hmm.
So. We will keep people updated. I think there is a lot of development going on right now as sort of implementation and adoption grows. We're finding more sort of cases where it's complicated and we need to solve those and issue appropriate guidelines afterwards.
Mm-hmm.
This is Suzanne. I'm just trying to make sure I understand what's being suggested here. So like a stream gauge, you could get an IGSN for, but then you would also have IGSNs for the water samples that you collected at that stream gauge, and those identifiers would be linked with a parent-daughter kind of relationship?
Yes.
That's absolutely correct, yes.
Okay. But weather station, that could have an IGSN even if we're not collecting samples there, or that part I'm still a little confused on.
I mean, it is. I think that's what Anthony was just saying. Verify that
so
even among us better. That could have. I mean, the issue for giving it a persistent unique identifier is again to reference that particular weather station without ambiguity, right? In any publications, data sets, and so on. So we could give it an IGSN, it just wouldn't have any children that are physical objects, right?
Yeah,
it would just stand by itself and be a unique identifier. That would be basically the solution I would find. But, you know, I was actually telling at the session yesterday that I just learned that cruises that have been done with the academic fleet in the U.S., cruise gets a DOI. And this DOI comes with a metadata profile. So there are certain fuzzy areas where you could take a DOI for an instrument. I know that NCAR has issued DOIs for airplanes and instrumentation on airplanes. So both are persistent unique identifiers. Both are resolvable back to a metadata profile that archived somewhere in perpetuity. So, you know, the application of these identifiers is sometimes very clear, sometimes, you know, could use different types of identifiers for the same entity.
Kirsten, you're cutting out.
Yeah, so I think the point is that equipment gets managed with, you know, make, model, and serial number, or something else. But a part of the earth, whether you bring it in the laboratory or you study it outside, is a sampling feature that can get an IGSN. At the top of our IGSN page, there's a link, and they're kind of subtle, but to define what a sampling feature is. And the Open Geospatial Consortium has this whole, kind of description of what a sampling feature is. And as Kirsten pointed out, it's being expanded upon right now with clearer definitions. But there's a hierarchy of related to the dimensionality of a sampling feature, and there are lots of examples of what sampling features are. So we'll do a better job of clarifying that on our website. If there's a question, please don't hesitate to ask us. I'm going to move on for the sake of time. There's still some other topics we want to cover, but this is a useful conversation. The next tab is geospatial, and this is really simple. It basically says that a data set listing on criticalzone.org, like the one you have here, this link here could be a set of shapefiles or KMLs or something like that. So that data file could be a geospatial file, and that's a way to share geospatial data. Because these files get pulled into the search portal, which is a GeoServer, there's the potential for us to build services around those shape files or KML files or rasters or other things. And so we haven't done that yet, but there's potential there. So we're kind of reminding people, don't forget to share your geospatial data. It's really no different than a CSV from sensors or a spreadsheet of geochemistry.
Oh, good to know.
Yeah.
LiDAR data is a special case of geospatial data that we have an agreement with Open Topography for sharing data. You all know that. I don't think we need to spend much time on that. The one thing that I'll mention, just to kind of describe things, is that I'm going to clear out some of these search capabilities, search terms, I should say. And what do I have linked here? We should have more than that. It was Patasso. Something is. Oh, we got lots of results. So I'm going to back all the way out. What you can see here is that we actually can link to the Open Topography LiDAR catalog because it's stored in a GeoServer. So this is the benefit of having these ISO 19115 metadata profiles stored in a GeoServer. So you can see that I can quickly do an Open Topography LiDAR search for Colorado and come up with some interesting information. Some of this is data that I'm sure you're very familiar with. So moving on to data DOI. This one, it sounds like you've been thinking about and actually have questions about. Kirsten and her team are also kind of leading with this idea of creating persistent digital object identifiers for data sets. And archival data centers such as IEDA, or now the Quasi-Water Data Center, have mandates to persist data and to track them using persistent identifiers for that data. So this describes what we expect, the benefits and outcomes, and here are the instructions. The first one is that we have a set of recommendations of what data center or repository should be used, and it's really based on scientific discipline. We recommend, here's our list right here, the IEDA EarthChem Library, Quasi-HydroShare, and the Quasi-Water Data Center as data archives based on the type of data that each specializes in. And each of them, IEDA has long had the ability to issue DOIs, and the Quasi-HydroShare and the Quasi-Water Data Center are beginning to issue DOIs for that data.
Yeah, I think that's where the majority, my question is, I mean, we have these ongoing data logger data sets, and I am planning on putting our chem data in EarthChem, but I'm not sure if my soil moisture data should go to HydroShare or Water Data Center, or what the benefit or difference is really.
Yep, we can, yeah. So HydroShare and Water Data Center, right, both part of QASI, are beginning to experiment and think about these persistent data archives. The QASI hydro server system previously didn't issue DOIs, but the Water Data Center now has a mandate to persist time series services into the long term. And so they're experimenting with having a Water One Flow web service endpoint for streaming raw data, for example, have a DOI. So this is kind of a very new thing, but you can see how the way this works is that, you know, the DOI can be resolved by the DOI organization, and when you click on that, it actually gets redirected to the current location where that information is stored. And this is an endpoint that a hydro server can read and do something with. So let me back up here to where I was. So that's kind of different. So for live data, you could issue a DOI for that live streaming sensor data. But for data that has been QA/QC'd and put into, you know, kind of a classic flat file format after being QA/QC'd, and let's say you've got, you know, 2011 Potasso precipitation data that you're not really going to touch, and you've chunked it out into a you know, a one-year record, like a lot of organizations do. At that point, it's really should be archived kind of in a persistent way, and that could either go to the EarthChem library. They can handle files like that, but HydroShare is trying to develop additional capabilities around that time series data, and EarthChem may be doing that too. EarthChem is getting more and more interested in time series data also. So HydroShare would be the place for that. Both EarthChem library and HydroShare are building services around YODA files, by the way.
So are those YODA files taking place of the CSV files that we're allowing people to download?
Yes, that is the intent.
So if I came up with another way to export this data, can I use JavaScript to create a YODA file? Do you know? You
could. You'd have to write that JavaScript yourself.
Actually, it's a JSON thing. So the Java, I mean, yeah, you would match a JavaScript object that's a YODA file, and it would output to JSON, and then there should be a way to output it to a YODA because it's the same kind of format. So.
Okay, I'll look into that.
Yeah. The short story about YODA is that it uses it uses the YAML syntax. YAML stands for YAML ain't markup language. It's kind of a funny computer science joke, I guess. But it's actually a very powerful superset of JSON, which can be read, which is JavaScript object notation, which can be read by any modern computer language. So all modern computer languages have YAML parsers. It makes the parsing of these YODA files seamless with any modern language. However, there are some semantic and structural conventions that we add on top of YAML to make it parsable into an ODM2 database. And we are building that using JSON schema, which is kind of like an XML schema, so that there are some rules for validating whether or not the YAML file is not just valid YAML syntax, but also follows the YODA file conventions for what's expected. And so there's a lot of possibilities there. That's why we did it this way. The old CZO display file format was basically an orphan. It was completely on its own. There was no modern computing system that could handle it out of the box. So the only parsers that were known were basically written by Tom Whitenack. So that said, sounds like that could be a lot of work, but we're building, as part of the ODM2 project, we're building in Python, not JavaScript, a whole set of tools that uses the ODM2 API and other things to validate YODA files, to create them, to load them in and out of ODM2 databases, and a whole pile of other things. But this is a work in progress right now.
Okay.
We should not say that we currently do not have YODA files for sample-based data yet, right?
That's right. We're not quite there with YODA files yet. The time series specification is pretty good, but for specimen data, we ran into some challenges in the way we were trying to basically create Excel templates that were choking. The Excel macros were choking, and so we kind of have to rethink that a little bit, and also some issues with the vocabularies. So I will say one last thing about repositories and then just try to move on, that for biological data, we recommend either the LTER information system, which especially for CZOs that are co-located with LTERs like your own, or Knowledge Network for Biocomplexity. Both of these are designed for archiving biological and related environmental data. And with all of these, once you obtain a DOI, the recommendation is that you replace all your links to data to that DOI. So for example, this link right here that you can see very fine print at the bottom of my page would be replaced by the DOI for the file, so that you're always actually getting the data from the data center. And therefore, your CZO is not on the hook anymore for archiving this data into perpetuity, or for persisting this data in the long term.
Yeah.
That's the goal. So once you hand it to a data center, you're no longer responsible for it, in a way, really. So we were not going to talk too much about that, but the last couple of things that we'll mention here, and then I think we'll try to wrap this conversation up, is that we spent an enormous amount of time, our entire team, building the ODM2. The concepts behind ODM2 were used for rebuilding the EarthChem database at IETA, for structuring a lot of the information in HydroShare, and the Quasi-Water Data Center is, now that it's functional, around the new cyber infrastructure, or excuse me, around the old approaches, but now in the cloud. So they kind of recoded the old Hydro servers and put it on the cloud. They're now interested in talking about adopting ODM2. It is the foundation for a lot of cyber infrastructure going forward in a lot of our tools. So it's kind of a conceptual thing, but there's real software behind it, and I was just pointing at some of these things. If you go to our ODM2 GitHub organization, you click on here, and there are scripts for creating ODM2 databases in any of these relational database management systems, and we know people who've implemented it in Oracle. So if you want some help there, the Luquillo CZO people and also at Arizona CZO are doing that. So where was I?
You said Luquillo in Arizona?
Yeah. So, but we can help with that. So ODM2 is a really great option for local data management. We're building a whole software ecosystem around ODM2, in addition to having it be this conceptual model that guided things like the YODA file, or guided the ODM2 vocabularies. They guided a lot of these data sharing principles, but we're also building a software ecosystem around that that is completely open and that we're willing to share. So you're not on your own, and it will really simplify things. The ODM2 software ecosystem is built around Python, so we've made that choice. But in terms of the actual relational database, it can be implemented in almost any relational database management system, but the code is all written in Python. We've created an API so that you can build software around a relational database. It's got built-in object relational mapping. It's kind of got all the bells and whistles. Well, maybe not all of them, but we're really thinking this through and doing a lot. So we would be more than happy to help you manage your data locally using ODM2 database. It's totally optional. The last thing, which is optional, is to help you with streaming data. Not at all necessary, but it sounds like you're all interested in it. There are lots of benefits for streaming data, and there are lots of ways for once the data is streaming to share it using various web services and standards such as Quasi's Water One Flow or using WaterML2 or other standards. And we can help you with that depending on which are the options that you want to use. So we present here a couple options, you know, and you can look through this list and contact us, and we can help you with that or point you to someone who can. Including that if you have a local data management in ODM2, we're building software to support streaming live data in and out of ODM2.
Cool.
That's the end of our little tour, and we have about 15 minutes left to the call. We spent a lot of time with some useful discussion there, but what we kind of want to do in this last bit is think about kind of next steps for how we can help you, and it can be either suggested from you or we can suggest it ourselves. We've talked about some of these things, and it might be useful to type in some of those ideas somewhere in this part of our notes file, and then we can try to follow up with it. Any thoughts from either the CZO data team about what the Boulder Creek CZO might consider trying or doing, or thoughts from Boulder Creek about what you might want help with?
So, yeah, Nate was just saying he's definitely interested in getting some help with the IGSNs and DOIs.
Okay, super.
Tying those into our system. For me, I'm going to look at, I'm going to go review those vocabularies and see if we can tie those into our new system. Because I think that'll just be a benefit to everybody. What else did I have on here?
Perhaps we shall touch base on the ISO 19115 files. In particular, take some of the files that you created and pass them through the pipeline and compare results.
Or
and
take the spreadsheets. Start with the spreadsheets. If they've already got those, we can just convert those ourselves. So they don't have to do anything and give them a tool.
So when you say spreadsheets, what are you talking about?
Well, you showed a spreadsheet that had the metadata that you guys were using.
That's our metadata request form,
Yeah, so.
So I just wanted to, this is Kirsten, just wanted to say if you need any help with or, have questions regarding IGSN registration or DOI, getting DOIs through the EarthChem library, we can set up another call, just a one-on-one, so to say, or you can directly contact Megan and work with her. She has a lot of answers to your question, I'm sure.
Yeah, that's a great idea. Actually, I think we'd really like to do that. Our group actually, we're right in the middle of moving buildings. They just built a new building that we have to move to in the next 2 weeks. So if we could schedule a date for sometime, what do you think, Nate, at the end of November?
End of November?
Yeah. End of November is fine.
Okay, that'd be great. I'll just have Nate email you then.
Our intent is to also have some more detailed kind of online tutorials, maybe live webinars to help out with some of these things. It seems like a lot of the CZOs are interested in both IGSNs and DOIs, so we'll probably have some type of walkthrough of the system. Megan and Leslie, who used to work with Kirsten developed specific guidelines for CZOs to use IGSNs with specific templates. So they could walk you through that process and then maybe have additional help after that or before that or whatever. But the sooner the better. We're very interested in kind of increasing the connections as soon as possible.
I would also like, I don't know if any one of you may be attending the GSA meeting in a few weeks. We have an early career scientist workshop that will have tutorials for IGSN and obtaining IGSNs on the Sunday afternoon before GSA started. So if you have...
I'm not going to GSA this year. This is Suzanne. But if you want to send me a link, you know, something about this this meeting, I can certainly send it out to everybody here to see if anybody. I'm not sure if anyone is going to GSA, but you know, I can send it out and see if.
Yeah, no, that would be great. We're actually offering, you know, students a free registration at GSA if they attend. It's part of the EarthCube iSamples Research Coordination Network, that workshop.
Yeah. You mentioned an AGU workshop?
Yeah, we will have, it's more of a sort of user forum for the IGSN. It's going to be on also on Sunday afternoon from 4 to 5. Location we don't have yet. I can send a message to all the CZOs.
Yeah, I already have something on Sunday afternoon, but there may be others who want to go.
Great.
I just pasted the link about the GSA iSamples workshop. I found a little story at EarthCube on it.
Suzanne, I'm going to forward you the invitation as well, so you have the full thing.
Great, thank you.
Mm-hmm.
So we have just about 5 minutes left to wrap up. I'll try and summarize some of these things in an email and make these connections. As we help you, there's two other things to mention. Well, I guess I already mentioned that we're going to try to have some webinars, but we're also hoping to have some workshops to help us continue the development of things like the YODA files. So if you're interested in participating, we'll be sending out invitations for data managers who really want to participate and roll up sleeves, because we're realizing when we've done these workshops that are very targeted, like the first YODA file workshop last February, that we really made an enormous amount of progress. And we're generating quite a list of them. There's some vocabularies that we want to iron out and some other things. So these aren't really tutorial workshops. You're kind of like to just finalize the decisions about certain little loose ends here and there with the project. So, and we'll probably have kind of a capstone IMC meeting sometime at the end of winter also for all the information managers like we've had previously. Beyond the current scope of funding, is there anything that you could imagine seeing our team doing or another data team doing to serve the needs of the integrated needs, the needs of integrating data across the CZO network, or for individual CZOs for that matter?
I have been wondering, Anthony, what I know the CZO integrated data grant ends in what, March? March. Yeah, and I have not heard of about any, what will go on after that, and as we both know, it's a process. It's not a not a one-time deal.
That's right.
And I was just wondering if you'd heard anything. I've actually, I've spoken with people at NSF about this. That we'd like to know that there is a next step. Just wondering what we're trying to put it, in other words, on their radar. And haven't gotten really, like, they're aware of that issue, but I haven't heard any plan on their part. Just curious what your plans are. You and your team.
I started trying to bring this up about a year ago, and NSF was kind of avoiding the conversation in many ways. You know, there's been lots of changes within this management of CZOs in the last year, and I think especially with kind of the review of the national office, I think they just wanted to wait to kind of let the dust settle. So I haven't heard anything, but I think it's clearly right now it's about the timing to connect. I mean, I was specifically asking quite a bit through the fall, winter, and spring all the way into June, you know, trying to talk to our new program officer, Paul Filmer, for this particular project, and just not really getting much information. So part of what we're doing is trying to see what you all need, because I think part of what NSF wants to know is, well, what is there a need, and what is that need, and did that need come directly from the CZOs, or is it a bunch of computer programmers who came up with that idea, right? Not.
Well, I mean, what I'm hearing from, you know, what you've been describing is that, you know, you've built ODM2, you've got these YODA files. I don't really fully understand all this stuff. There's working towards getting, implementing IGSNs, DOIs for data sets, but we're just starting down that pathway. And so they're really, you know, it hasn't been fully implemented yet, and I'm sure that there are pieces that still need work, and probably will need to continue to be developed as we move along. I know you also put a lot into visualization, which we haven't really talked about so much today.
No, that's right.
And that is something that you know, it gets old pretty quickly. Gets superseded by something, you know, something else pretty quickly.
Yeah, that's right.
So I've been expressing to NSF the fact that it's, you know, it's not done, that it's started. You've done a lot of good work to get us to where we are, but you still can't. I'm not sure that you can, at this point, really go into the critical zone search. I hadn't really examined that before and find a whole lot of things yet, because we're still in the process of connecting all these parts, right?
That's right. You know, a lot of these services had been built, but we were so focused on finishing the you know, other parts of the services and kind of getting our little ecosystem finished, that even the things that were ready a year ago or a year and a half ago hardly got used because we weren't really adequately training and promoting them. The whole system is 90 to 95% ready for use, with probably the exception of YODA files, and maybe and most of it has been ready for quite a while. And really, right now, we need contributions. You know. And we really want to have you all get started, and because we can't do the job of linking the data and making things look good, and kind of the visualization system we created was kind of designed as a prototype to show what's possible once we get all this data in the system, right? viz.criticalzone.org. There wasn't really a full amount of funding there, and viz.criticalzone.org doesn't look that great because, frankly, there's not a lot of data there to connect to of the right types or whatever, right? At least not consistently across all the CZOs. So that's what we're trying to do, is just kind of connect all the dots.
Yeah.
And with your help, right? I mean, there's only, we can't submit the data for you, and at the same time, it's pretty clear that we haven't really been working closely with you all on how to do it. So that's what these conversations are about. So I'm really grateful that, Suzanne, you attended this, and we got a bunch of other people to attend to kind of see what parts you've got working really exceptionally well, and what parts we could assist you with.
I guess one thing was I was always under the impression that the integrated database was going to harvest from what we put on the website, but it sounds like we actually need to submit it to the integrated database. Is that what I understood?
I don't know.
No, what I understood was it's going to be harvested.
It will be harvested?
That's what I understood.
It sounds like it'll be harvested. We just have to put it up there in the right format.
Okay.
Yeah, so let me describe what that means. We will harvest all the metadata for any file that you post as a data set listing on a web page like this one at criticalzone.org.
Okay.
If the files are of a certain type, we will actually also harvest the data. We don't have an archival data center mandate. So even if we harvest the data, it will only be for temporary purposes of search, discovery, and display and integration and things like that, because we're not a data repository.
Right.
So CZO display file version 1 is what we had been harvesting previously. We can continue to harvest those files without really a problem, but we are transitioning to these YODA files, and that's kind of the last thing that we need to get underway. If you want to get started with time series YODA files, which are basically a one-to-one replacement for the old CZO display file, we actually could start. We've been ready since I don't know, April or something like that with those, or May. For the specimens, which there really wasn't, which I guess are the specimen YODA files, which are going to be replacing CZChemDB. That's not ready yet. If you want to, load up your chemistry data in CZChemDB Excel files, we can handle that. We've asked Sue Brantley to no longer put new data in the Microsoft Access database that she was maintaining, because that was kind of a mess. But the Excel spreadsheets, those templates, that's a fine place to put that kind of data until we have a replacement with the YODA files. So that will be harvested by us. But the best thing to do is to actually put those CZO display files and anything else in a repository like AIDA EarthChem or HydroShare. Those YODA files, those CZO display files, when they're there, they're both archivable and we can harvest their information and display them.
So is the specimen YODA file, is that something that is going to get completed by March, or is that something that is something we need to point to as, this is one of the things that needs to be supported in another, with another funding mechanism? I don't know if grant is the right way to do this anymore,
We were hoping that it would have already been completed, so we feel a little bit behind schedule, and I'm kind of one of the main architects of that, so it's kind of, that's been on my plate and one of my
the moon, Anthony, and we get somewhere.
Yeah, one of my challenges. So the thing is that we're gonna have something that's functioning before too long. What we will need after March will be probably more resources to build services about how to create them and ingest them and do things with them, with those files. So to make it easier for users to use them. So the YODA file, the CZO display file was good for time series. That's about it. Hydrological and meteorological time series. It didn't really work for other things. The YODA file can handle just about any data set you can think of, aside from the really complex geospatial stuff. But almost all other files it can handle, but because it's so flexible, we need to guide people on how to use it. And that was part of the problem with our first template. It was a little too, needed a little more guidance. So what what we'll be doing is we've developed these profiles for YODA files with templates that are very specific to certain data types, so that the language that people see makes sense to them, so that there are limited options, so that it's not overly confusing. And the idea is that any graduate student or investigator could fill out one of these templates, and it would basically be slurped into something that would then generate a YODA file, probably some online software. So you'd load up this Excel template, and it would spit out a YODA file or something like that.
And just to add to what Anthony said, as you know, temporary arrangements can quite often be fairly long-term. And you know that we've been harvesting these CZO display files and archiving them for last 5 years or so, 4 years. And of course, they need to get permanent home because we operate as a project, not as a facility. So we're working with, as Anthony said, several projects that will be more permanent home for these files, but the schedule of actual transitioning depends on their schedules as well. In the meantime, your files are not disappearing. We'll still manage them and make sure that they are handled and transitioned in the right place.
Okay. You know, another piece of this, Anthony, is that there's always a need for, I don't know, training, reminding us, helping us. I usually have Jerry and Eric talk to my CZO people, you know, the scientists, the students, you know, as often as I can get them to talk, just to remind people that we're here, we want your data, and it will help you. And that's, I mean, it's true at your level as well. So yeah. I think that's you know, we always need those, I don't know, brush ups on that, if nothing else. I know I need to get back to the phone call that came in the middle of this.
No worries. Yep. It's time to wrap it up. So thank you all for your time, and we'll be in touch.
Yeah,
thanks
you
so much.
Anthony.
This is really great.
Yeah, it was.
Super. I'm glad it was helpful.
Thanks.
All right.
Thanks all of you.
Bye. Thank you.
Bye-bye.